I'm Frank, and today we're going to work on quadratic factoring part 2. We've already posted quadratic factoring part 1, and now we're continuing on that. If you recall, this is a review of a lot of different types of factoring. Today we'll talk about general quadratics, where we break it into two parentheses. There's difference of squares, there's perfect trinomial squares, and the last one's interesting. It's like a challenge. It's a combination of perfect trinomial squares and difference of squares. So we have today 8 examples. So let's look at so this is our general quadratic. Ax squared plus bx plus c, where a is not 0. So our first one up here, yesterday we did a lot of, or part 1, we did a lot of quadratics where the leading coefficient was 1. Well, if the leading coefficient was 1, we didn't even have to hesitate. We just put m and m. But now it's 2m squared. But that's not too bad, because 2 only has one set of factors, 2 and 1. So if it's going to factor, it's going to have 2m and m. Now, this sign being negative tells you that one side's positive and one side's negative, but we don't know which one. So we explore. Now, there's different ways to do this. I've heard people talk about different methods, but I've had the best success in just telling them that they have to sort of distribute in their head. So I said, I'll ask them, give me 2 numbers that multiplied at 21. And needless to say, they'll pop out 7 and 3. Okay. I say, well, where would you like to put the 7 and 3? Well, you could put the 7 here or the 3 there. So a lot of times I like to do one that may not be the exact answer. So let's put 7 and 3. Because when students learn how to check, then they're more likely to get it correct. Now, I'd say now one sign's positive and one's negative, plus or minus. So I ask them, what's that give you? And they'll respond 7m. What's this give you? And they'll say 6m. I say, now look, one's plus and one's minus. So we're going to subtract either 7 minus 6 or 6 minus 7. And we're either going to get 1 or negative 1. But you need 11. They'll say, well, that's not going to work. Exactly. So let's switch them around. 3 and 7. Now this is going to give you 3m. And this is going to give you 14m. Now if you subtract 14 and 3, you either get 11 or negative 11. Ah, negative 11. That's what we need. And here's how we can get it. So you say, all right, that'll give us negative 11. So we need this one here to be the negative, and this one here to be the positive. And you could multiply it out. 2m squared. 3m, take away 14m is negative 11m. And 3 times negative 7 is negative 21. All right, so as you get better at this, more experience, some students can do these near about in their head. They can just write them down and factor it. Other students, trial and error, but with practice, I promise you'll get better. Okay, our next example. Now this one is a little more interesting. 16 has a lot of factors. Do I try 1 and 16, 2 and 8, 4 and 4? I don't know. Even if I knew, I'm not going to tell you. I'm going to let you figure it out. So if I ask the student what to do, it's interesting. I usually take whatever they say. So what would you choose? You could try all different possibilities, but maybe since we're on a video, we don't want to just go over and over and prolong this. So let's try 4x and 4x. let's just give this a try. Now, this sign tells you they're different, plus or minus. But we don't know which is which. So, what are multiples of 15? Well, let's try 5 and 3. One's plus and one's minus. Well, this will give you 20x, and this will give you 12x. Aha. 20 take away 12 is 8, but 12 take away 20 is negative 8. That's what we want. This gives us our negative 8. So we need a negative 20, so this one's a negative, negative 20, and this is the positive. And then if we FOIL it, let's check it out. This gives you your 16x squared, negative 20 plus 12 is negative 8, minus 15, and there it is. So there's our second example. All right, our third example, the only thing we have here is two variables. 7's a prime number, so the multiples of 7 are 7 and 1. So we'll put 7s and 1s, and if you choose, you can put the 1 and the 7. Sign's negative, so that says they're different. Now, let's try one. Let's just try whatever comes to your head first. Suppose you try multiples of 7 or 3 and you went like this. And since this doesn't have as many possibilities, we're just going to take any one we think of. Well, this will give you 3st, and this will give you 7st. And if one's positive and one's negative, you're either going to get a 4 or negative 4, and that's not what you need. You need negative 20. So you say, all right, so let's make that the 1, and this is the 3. This gives you 1 TS, this gives, or ST, this gives you 21 ST, and wait a minute, if I subtract them in this manner, that gives you the negative 20 ST. So we want this to be the positive, and this to be the negative. And there you go. If you FOIL it, 7s squared, 1st, take away 21st. 1 take away 21 is negative 20, negative 3t squared. There you go. Okay. Our next example is what's called the perfect trinomial square. Now let's see how it makes that name up. Trinomial. 1, 2, 3. Trinomial. Square. 9m times 9m. 4 times 4. Now to be a perfect trinomial square, the middle term has got to be 72. So let's see if it is. So a perfect trinomial square. Take the square root, 9m, 9m. This sign's positive, so the signs are the same. This is what they are, plus. Now, if this is, okay, square root. So we got a trinomial, and there's your squares. Now, is it perfect? What's this give you? 36m. 36m. We add them. There you go. Now that's a perfect. So this makes it perfect. This makes it a trinomial. And these two numbers are the squares. Now, if you wrote this, you're correct. But in a more concise form, it can be written like this. Whenever you multiply something by itself, why not just list it once and square it? So that's a perfect trinomial square. Okay, our next one has a name of difference, subtraction of squares. 6z times 6z, 7 times 7. Difference. Notice there's no middle term. You need that to cancel out. Add to 0. So you take 6z and 6z. This tells you they're different. Take the square root of 49 and 7 and 7. So there's the difference. Here's the squares. Now let's see why this works. That gives you 42z. And that gives you 42. No, I'm sorry. One's plus and one's minus. One's minus, because you need a negative. One gives you negative 42z. So there's the 42z. There's the negative 42z, and they give you 0, which is nothing in there. So in this case, this this difference of squares, you take the square of this one and the square of that one and change the signs in between. And that'll cause the middle term to cancel out. Okay, the next one is another difference of squares. Just threw some fractions at you. It's all right. It's a difference. The square root of 1/16 is 1/4 z. 1/4 z. You need a plus and a minus to give you this negative, and take the square of that, which is 3/5 a. 3/5 a. And this will be 3 over 20 az. This will be negative 3 over 20 az. And they cancel out. So there's your answer. So this is what's called a difference of squares. Our next example is another difference of squares. It just looks intimidating. So I showed you one with fractions previously, and so let's look at this. If you e to the 31st times e to the 31st, remember your rules of exponents, you would add them, and that would give you 62. And of course, 50 plus 50 would be 100. One's plus, one's minus. 72 plus 72 is 144. And then 18 plus 18. So what you're doing is saying, well, just half it. Because remember, when you multiply, you add exponents. So it looks very intimidating, but it's a difference of squares. And usually with enough practice, students learn to recognize a difference of squares. Now this last problem is like a little challenge. Be a great problem for SAT or a great problem for a class. So let's look at this. You say 4 terms, how do I do it? And why'd you group the first 3? Well, grouping the first 3 gives you a little hint. Could I factor the first 3? Could I factor the parentheses? Trinomial, 1, 2, 3, squares. I wonder if this is one of them perfect trinomial squares. Well, we know it's a trinomial. We know it's squares. Now, this is perfect. That gives you negative xy. This gives you negative xy. And you combine them and get negative 2xy. So you say, hey, that's the first one. So let's write minus c squared. Now, what did we say earlier? When you have a factor times itself, you can square it. Is that all right? Now let's look. This is 2 big terms. Term 1, term 2. This is a square, and that's a difference. So that's a difference of squares. So how do we factor a difference of squares? Now, initially, I'm going to use a bracket, which is used after a parenthesis, and I'm going to put x minus y and x minus y. Because if you multiply these two, you'll get the quantity squared. And there's your difference, one's plus and one's minus, z and z. Now, that's an answer, but if you were to take an assessment like a multiple choice, they would probably write it like this. They would not group them x minus y's together. They would just go like this. And that would probably be the preferred answer. So that one combines them. Very nice problem. It's one I know you can get. So these are our two basic lessons on quadratic factoring. I hope you found them informative, and stay tuned for our next one. Have a good day.